If you click this video at one point away, then please tell me what the reason was, so that I can improve. Otherwise, I'm welcome. I'm trying to learn astronomy today. Constellations of the night sky, and after we've done that, we're going to do body center training. And if you participate in the body center training, then it's at your own risk. Constellations of the night sky. Star maps that derive from ancient times. Early astronomers could do no more than make naked eye observations of the sky and record its changing appearance through the year. They had no telescopes, so they just could look from the Earth out into the sky with their normal human eyes. And then they were writing down, they're seeing their star, their star, their star. They were writing that down, and a day or week, a month later, they have written down where see they now. Where see they them now. They divided the sky into star groups or patterns of stars called constellations, which modern astronomers still use to help identify stars and other celestial objects. Okay, they saw some pattern there, so they said, these three over there. There were three in the bunch, or these five over there. So that's basically what we did. This is what I understand so far. There are in all 88 constellations, 48 of them named by the ancient Mediterranean people 2000 years ago, before the time of the Greek astronomer Ptolemy. Okay, there was at some time the Greek astronomer Ptolemy. Copernicus was the first great astronomer of the Renaissance, so 4540. By his time, it had become clear that Ptolemy's predictions about the positions of the planets were incorrect. When was Ptolemy? For 1,400 years after the 2nd century, Alexandrian Greek Ptolemy produced his complex Earth-centered theory of the universe. So 200 years earlier, I think. I think Ptolemy lived in the 2nd century from that. So, but it's not that important. The people at the Mediterranean Sea, they made out 48 constellations. And that already before there was Ptolemy, probably in the 2nd century. Other constellations were plotted and named by star mappers such as John Bayer, Johannes Hevelius, and Nicolas Louis de Locke in the 17th and 18th century. So there are 88 constellations, so these 3 over there, these 5 there, these 4 there, and 68 of them more. And they were found together over time. The ancient astronomers identified characters and events from mythology among the star patterns, rather like the join the dots pictures found in children's books. Okay, they did not say these 3 over there or these 5 over there, but they said these 5 over there, like the last bowling match which we had at last, the last 5 were standing there. Many of the constellations do not represent the imagined figures very closely, and they are often depicted differently on different maps. So maybe we should repeat the sentence clearly. They don't often represent in the clear defined forms what they are named. So some, and they're also then described in other books with other words. Some people say a match result of a bowling match, other people might see something completely else. So they're saying here it's normal maybe to see something different. Or nothing more. However, the ancient astronomers probably did not intend the resemblances to be taken too literally. Okay, they are saying here that it is assumed that when the people said that represents the last bowling match, they didn't literally mean that was so. That they also said, or if they had a story behind it, that did not actually happen there, or that thing is not actually that. The main constellations and their brightest stars are shown on the charts below. Here. An observer situated at either pole of the Earth sees only the stars of that hemisphere. So we're having here on the one side the north and the other one the southern hemisphere. If someone is at the North Pole, they can't see what is with the stars on the other side. He would see them revolve around the celestial pole once every 24 hours. So it would somehow turn like that. I don't really understand it. he or she would see them revolve around the celestial pole once every 24 hours, with none rising or setting. Such stars are described as circumpolar. But for an observer on the equator, all stars rise and set. So what I mean is, if someone is at the, I have a globe over there. If someone is at the top of the Earth, they are seeing the stars always the same, because they basically don't change. They're looking all the time just upwards, and it doesn't matter. They can turn it around, but we can still see upwards. If someone is at the side, it's around, so they can't see what is here. The person here can always see what is where. They're just turning on the spot. Like someone, imagine someone running big rounds in a stadium. Someone does it far outside at the equator, out the big running tracks, and the person standing in the middle. The person in the middle just have to turn around and makes technically the whole round. Someone 5 meters away has to run a little round, and someone far away has to make a back round. And the person far away can't see all the time all these things, because now there are things in the way to see. It somehow makes sense, and somehow my explanation isn't accurate enough to really explain it. The celestial poles lie on the north and south horizons respectively. And during the night, stars rise in the east, move across the sky, and set in the west. It's the same with the sun. If you have the North Pole, you have very long sun or very long night, because the sun is all the time there. You turn differently because you're up there or down there. But I'm not completely able to explain it right now. Otherwise I would. Over a period of 1 year, an observer at the equator would see all night of the stars of both hemispheres. So we're turning around. So not the stars are moving, the Earth is turning. And that is why we can't see them all. But I don't really understand now how. But I think that is one important thing. It are not the stars turning, it is the Earth turning. And we're saying over 1 year, so it's not 1 day in which the Earth is turning, so that we're seeing them in the night rise and fall or something, rising in the east, falling in the west. So like that, just like the sun over the course of the day. It is also that we're turning around with the Earth around the sun. And now we're seeing a different part. Maybe that, imagine here are the stars. We just see, for example, let's take here Andromeda. Where's Andromeda? Now the people here on the equator can't see it because the Earth is away. They're here at the equator and the Earth is here around, they can't see it if it's here. Now if we come now to some other place, for example here, 9 months later, around the sun, they can see it. What was it? And that way we can see it. So it's something like that. I think I'm getting closer to having an explanation. At other latitudes, the situation lies between these two extremes. Most people, therefore, can see some stars of each hemisphere in the night sky. Some stars will always be visible near one of the poles, circumpolar stars, while the presence of others, which rise and set each night, will change with the seasons as the Earth orbits the Sun. So I was saying, someone at the equator can see all over the course of a whole year. Someone in the middle, not. But we can see some always and others not always. I don't really know why. Because we're still unable to see the ones in the south? I don't know why. The diagrams below indicate constellations that lie to the south or north in the evening, as seen during the year by observers in mid-northern and mid-southern latitudes. Okay, this is for people in the mid-southern or mid-northern latitudes. So Central Europe, or also mostly Asia, North America, but also Central South America and South Africa. The stars that form constellations are relatively near to the Sun in our own galaxy, the Milky Way system. Okay, the stars seen there are close, relatively near to the Sun. This appears as a band spread across a star chart. It is in fact a disk of millions of stars, which we, I mean the humans on Earth, see in cross-section from other places within the disk. The stars that form constellations are relatively near to the Sun. In our own known galaxy, the Milky Way system. This appears as a band spread across star charts. It is in fact a disk of millions of stars which we see in cross-section from our place within the disk. What we mean is the Milky Way is basically a big disk with millions of stars. I think it was 100 million or 100 billion. Many stars, and the humans are on the side arm on the Earth. And we can see now, if we're looking out, some stars in this big band, also some out behind and in front of them, around them. And they are part of the Milky Way, but we can also see a part of it. An entirely separate galaxy from our own, so we mean again the Milky Way, the Andromeda galaxy, containing also many millions of stars, can be seen as a faint misty patch of light within the area of a constellation Andromeda. So I was saying here Andromeda is marked here. If we see the Andromeda, we don't just see another star there, but another galaxy. The Andromeda galaxy is a complete new galaxy, again with millions, hundreds of millions of stars. Our galaxy is slowly rotating, and all the stars within it are orbiting with different speeds about its center. The Sun takes about 225 million years to go around once. Therefore, over millions of years, some stars seem to move ahead of the Sun in the sky, while others drop back. These slight star movements, unnoticed by the naked eye in a human lifetime, are detected by accurate measurements through telescopes. The steady movement of a star in the sky is called its proper motion. The proper motions of stars build up over long periods of time, eventually distorting the constellation shapes. Although there have been no major changes to the constellation shapes since they were first outlined by the ancient Greeks, the diagram on the right shows how one familiar star pattern looked at the dawn of mankind, sort of humankind, of man and woman, and how it will look some 200,000 years from now, so we mean the 21st century on Earth. The moving stars. Because of the steady movement of stars, constellations change shape over hundreds of thousands of years. So we're moving with this. They mean the whole Milky Way is turning. And the humans are peacefully on the Earth in one of these arms of a big Milky Way with lots of these arms. And over time there's some other places. And some things are turning faster than other ones. So a star which is here closer to the Sun, I would think now, turns faster around the Sun than one is further away. We were having that in space science. We had a little wondering about why the Milky Way is spiral shaped, so with these arms to the side. And there was one idea because another is colliding with it. That is happening, and that might be making it to it. But what if it's just turning and the things at the outside are just slower? Or whatever, that was the astronomy part. If you were here for astronomy, you can go directly to the next part of astronomy. We don't have time, so maybe you're going to do with how text again in the next part, maybe something, I don't know. If you were here for astronomy, you can go directly to the next part of astronomy. If you stay here and participate in the body-centered training method at your own risk, leg up, pull the leg up, point of the toes down. Now leg. Leg up, and right angle with the leg, flex foot, even line hips, turn off the back, and press from the top against the knee. On the side. And press up to side. Side. Press on the outside. Out slowly. Close again. Other leg up. Press on the top. Side. Press up to side. Press the outside. Out slowly. Close again. And we're having 3 exercises on the ground left. First the side leg on the elbow. And now if you like, you can one leg up. Now on the long arm. One arm out, leg up, and pull knee to elbow. And over to the other side. First on the elbow. And one leg up. Now on the long arm. Arm out, leg up, and pull elbow to knee. And up again. One knee again up. Other knee up. Legs to the sides, still breathing in, down, down. And out again. And in. Breathe in and cross the legs. And breathe again out. It was the fast and body center training. I thank you very much, and until next time.